All right, guys. I had a lot of people ask me to make this a video because it was a lot to absorb during class time, so I wanted to go ahead and do that. I was able to find a free moment. So let's look at this. I'm being asked to verify that this will always yield 0, or is always going to be equivalent to 0. And to do that, I'm going to keep a couple things in mind. I may want to use my most important Pythagorean identity, sine squared plus cosine squared equals 1. And I may need to employ some of these tips and tricks like rewrite in terms of sine and cosine, or try to replace any trig function squared plus or minus 1 with some variation of our favorite Pythagorean identity. Here we're probably going to do 2 more than 1. The first thing I want to do is ask myself, can I go ahead and add these together? Unfortunately, no. I have different denominators. So the first thing I need to do, let's keep in mind that we're aiming to show that that's equivalent to 0. But what I want to do here now is ask myself, what does this denominator have that this one needs? And what does this denominator have that this one needs, so that they're equivalent, so I can add these together. So I'm going to go ahead and draw my brackets to remind myself. Very soon I'm going to be recording or multiplying by something. Here, there's nothing in common for either denominator. So I'm going to multiply this by my special 1. I'm allowed to multiply anything by 1 without changing what I have. So here I need this to have a sine of x and a sine of y. I'm going to multiply sine of x plus sine of y, or just copy my denominator here over itself. And this is allowed because anything divided by itself is 1. So at the end of the day, I'm only multiplying here by 1. This was going to be a little bit harder to see, so I'm going to have to smush it in there. But this time I need some cosine x and cosine y here. So I'm going to make that special 1 in terms of cosine x, cosine y over cosine x times cosine y. And if I divide that out, I'm just multiplying by 1, which is always allowed. So if I do that, I just need to be able to FOIL these. I can't find my purple marker, so we can't color code it right now. But let's do sine times sine. Then we're going to multiply that times sine x times sine y. And I've had a lot of questions saying, well, why don't we just square it and make it sine squared xy? These are two different numbers. They have different variables. We're going to avoid doing that. Now I'm going to multiply my insides, sine y, so negative sine y times sine x, so minus sine y, sine x. And I'm very clearly seeing I'm probably going to run out of board space here in just a second. And then I'm going to have negative sine y times positive sine y. Now those are exactly the same, and anything times itself is squared. So I'm going to have negative sine squared y. Now, I have this from this. And I went ahead and got that out of the way. I'm going to multiply this through next. And if you're watching the video, some of you may be frustrated that I haven't dealt with this yet. Oh, I want to deal with this because the reason we chose to multiply this side by sine of x plus sine of y over itself is it's going to force these denominators to be the same. So I'm going to take care of that in this step, and then we're just going to bring that right on over for us. Our goal here is to force our denominators to be the same so we can add them together and go from a binomial to a monomial. So let's distribute our cosine times cosine. That's cosine x times cosine x, and then cosine minus negative times negative cosine y. That's cosine x, cosine y. And I went ahead, instead of writing cosine x times negative cosine y, I moved the negative out front just to make it a little bit more compact. So I've dealt with my first and my last, or my outer. Let's go my inside. Cosine y times cosine x. Both are positive, so I'm going to have cosine y, cosine x. And then I'm going to multiply through here, and I'm going to have minus cosine, that is a horrible cosine, minus cosine y times cosine y, cosine squared y. And let's go ahead and bring, we already know this part, so let's go ahead and bring that over. And please don't waste your time doing this. I could be able to sneak this whole thing in there, but it gives me a chance to talk about the fact that here, if I multiply two binomials times each other, I should get 4 terms. And if I do that again, I should get 4 terms. I should have known better than to think I was going to sneak 4 terms on this board. Now, I'm going to do all of the work, but I want to point out something. My goal is to show that this is equivalent to 0 when I add these together. The only way I'm going to turn this into a 0 is if my numerator is 0. Remember, 0 divided by any real number is 0, and any real number divided by 0 is undefined. So there's no point in trying to force a 0 in my denominator. So if I was doing this for myself, I would just say let d for denominator equal the product of this plus the product of this times this. But I don't want to skip that on the video for now. We will do that in the next step because I don't want to keep writing these things. Here I have cosine. I left my plus out. That's where I paused earlier, right? Here I have cosine x times sine x. They're not the same, so nothing changes power-wise. Then I have cosine x sine y. And I've only done these first 2 distributions. Now I'm going to have plus cosine y times sine x plus cosine y sine y. But why? Well, now I've done that. I'm going to get the same thing. They may be in a different order, but I know this is going to force them to be the same. I'll do it anyways. Thank you to Ms. Sanchez for donating these markers. If I paid for them, I'd probably be more reluctant. Cosine x times sine x. Order is different because I did it this way. It's fine. Cosine x sine y. Now cosine y sine x. And all I'm doing is just foiling for most of this problem. And then cosine y times sine y. I'm going to look this over, and the way I'm going to check if I did it right is, well, here I should have the same variable. Then I should have alternating functions and variables. Then I should have alternating functions and variables. And then I should have same variable alternating. Let me double check that I've done this part right, since this is kind of a problem that a lot of people had questions about. Do I have a cosine x sine x? Let's verify. Here it is, so that's safe. Do I have a cosine x sine y? Cosine x sine y. Do I have a cosine y sine x? Cosine y sine x. And all I'm doing here is making sure that my denominator is exactly the same on both of these, so I can just bring them together. So I went ahead and verified everything. So now that I have a binomial fraction and I have the same denominator, I can rewrite this fraction as this numerator plus this numerator all over just this denominator. So let's do that. And some of you may be looking at this and go, why don't you go ahead and simplify it now? Usually, I like to wait until the end because if you're having questions, you want to see everything moved and then canceled all in one step. So it just for some reason seems more cozy. So let me double check. Cosine squared x minus cosine x cosine y. I missed something. Let's start it over instead of me talking about being cozy. Cosine squared x minus cosine x cosine y plus cosine y cosine x minus cosine squared y. And now that I've recopied that, I'm going to join these. So this is going to be plus sine squared x plus sine x sine y minus sine y sine x minus sine squared y. All I've done is combine this numerator that I had on the left from here over with this numerator I had on the right from here over. And that's all over the same denominator. I'll even match this swoop. So now I'm just going to copy. I'm going to do the right one for my denominator since I've already shown it's equivalent and I can multiply in any order. I can add in any order. It doesn't really matter as long as I have every term accounted for with the right sign between it. I will be okay. And again, our goal is just to make the numerator equal 0. So it doesn't matter what's down here. These are all just numbers, right? Sine of y, cosine of y, all numbers. I just need to get the top to 0. So when I divide 0 by this, it leaves me with just 0. So I have cosine x, cosine y, and that's negative, plus cosine y, cosine x. Now the order's in reverse, but since it's multiplication, I could flip them. And now I have positive and negative, same thing. So that will cancel with that. Then if I come over here, I have sine x, positive sine x times sine y minus sine y times sine x. So that's going to cancel. And then we're going to be left with not a lot of room on the board. And we have cosine squared x gone, gone, minus cosine squared y. Gone, gone. Cosine squared x minus cosine squared y. I didn't copy I crossed the wrong part out. Got a little overzealous there. So next I have plus sine squared. Usually you guys are here to yell at me for that. At least call it to my attention, I should say. And minus sine squared y. That's all over this denominator. What we're going to call d. So we're going to say that this let d equal that. Cosine squared x can't subtract because of that mixed variable x and y. So we have two choices. We can accept the partial credit here and move on, or we can keep chugging along, and since it's getting very busy here, I'm going to erase all of this and then we're going to keep working. The only thing I want to point out again is that This D, this capital D, represents this denominator. So I just wrote it here so I don't have to keep writing it out because we don't want to do that. Because again, I want it 0 in my numerator. Now in class, somebody pointed out and said, oh, I just subtracted cosine squared. I have a positive cosine squared and a negative cosine squared, so I just went ahead and canceled those out. You could do that if the variables were the same. Since they're not, we need to be able to do just a little bit more. So from here, let me rewrite it nice and clean. All right. So we rewrote it, cleaned up the board. This was our simplification after we got rid of all the linear terms. And then we had that denominator that I didn't want to keep writing. It's taking up too much space. So I said let D equal the denominator. That's my goal again, is to get 0 divided by some real number. And these all represent real numbers, at least for now. What I want to do now is group my terms together, like my x's and my y's together. So let's rewrite this as cosine squared x plus sine squared x minus cosine squared y minus sine squared y. And of course, that's all over that cumbersome denominator that we're trying our best to avoid. Now, because I rearranged some of my, or I rearranged and grouped by like variables, the order I add these doesn't matter. Sine squared plus cosine squared is equal to 1. So cosine squared plus sine squared is also equal to 1. Here's a little bit different, so let's deal with that first. Let us instead factor out this negative sign, and I'll show you the steps for it. Because I factored the negative out, that becomes positive. And of course, that's still over that same giant denominator. Now I can see here, cosine squared plus sine squared, well, cosine squared plus sine squared is equal to 1. And now because I factored that out, I have a negative sign there. So I have 1 minus 1 over that crazy denominator. It's going to give me 0 over that crazy denominator. And it doesn't matter what the denominator is, as long as it's a real number, it has an output in the system we're working in, which it does. 0 divided by any number is 0. So we have shown that, now shown that that is true. If I choose values for x and y, they will cancel out and leave me with 0 over something in the denominator. And 0 divided by anything is 0. If you requested this video or like extra help, of course it didn't work on video, thank you, and I hope this helps.